So my task was to use the garden as a teaching tool. So I decided to put up a program, a presentation together on introduction to fractions.
Sure, thank you.
One video.
Okay, so I want to begin with a few definitions. What is the definition of a fraction? How do we define fraction?
A fraction is part of something.
Part of a whole.
Okay.
Part of something.
A fraction is a part of a whole.
A part something. Not a whole, something. Because from a whole you can get a fraction, and from cutting a fraction you can still get a fraction. So the right thing is a part of something.
Okay, so a fraction is a part of something. Okay, it can be a whole or it can be a part of another fraction. Okay, and we are going to get to that today. So thank you for that input. Okay, but we're going to begin with one whole thing. Okay, so a fraction is a part of something, or a fraction is a part of a whole, divided into, we'll say, equal pieces, all right, or equal fragments. Okay, how many of you have observed that the symbol for a fraction is a division sign, or how a fraction is presented? Okay, the division sign is in the same format in which a fraction is presented. Okay, so a fraction has a number at the top, a line, and then another number at the bottom. Okay, the number at the top is what? What is it called? Okay, so the top number in the in a fraction is the numerator. And the bottom number in the fraction is denominator.
On the line.
Okay? So the numerator is the top number in a fraction and it's divided by the denominator.
And the line is called the fraction bar.
And the line is called the fraction bar. Okay. Thanks again. And then the denominator is the bottom number and it divides the numerator. Okay? Okay, so we're going to use our watermelon as our one object. So we have this one watermelon and we cut it in two pieces. Okay, so one, and then we cut that one into two pieces. What is the value of each piece?
1/2.
The value of each piece is 1/2. Okay? So we cut. Now, to make reference to Miss Willoughby's input earlier, we're going to take a fraction of this fraction. We're going to divide this fraction. Okay, so we're going to cut each half into two pieces.
I volunteer to do it.
To cut?
Yeah.
Sure. Sure.
Here come the knife skills.
Here's my knife skills. Forget that. Okay. I wasn't trained like that, and I still have all my fingers. Can I cut at least one half?
Yes,
around?
cut both halves in half.
In half.
Okay, so what is the value of each piece right now?
Out of 4.
Okay, there are 4 pieces, and each piece is one of the 4 pieces, right? So each piece is what fraction now?
1/4.
Okay, 1/4 or a quarter. All right, I'm not finished with you yet.
Okay.
Okay, so we're going to divide this fourth into 2 more pieces.
So I'm cutting each
No, you could cut it the other way now.
Okay.
Make it a little easy. It doesn't make a difference really, but it might be a little easier to cut it that way now.
Not there, right? Is it? Or that's a white watermelon?
That yeah, be far
And I said, I said, let me watermelon to this.
more.
I know I said I would take, but when I see
All right, so we divided our 4 pieces, each of the 4 pieces, into 2. Okay, what is the value of each piece now?
1/8.
1/8. Okay, so we have 1/2, 1/4, and 1/8. All of these are common fractions. Right, Ms. Cohen? Okay, good.
Can you hear me again?
Yeah, you could just stay here.
Okay.
Okay, so what I want you to do is add 1/8 to 1/8.
Take one. It's 1, 2, 3, 4, 5, 6, 7, 8 pieces.
If you could match them up to the ones that they originally
Okay.
cut them from, that.
No problem. Yes. So all the 1/8s just match up and put them in pairs.
Yeah.
Okay.
Okay. So when you add fractions, you don't add the denominators. You only add the numerator. Okay? But the denominators have to be a common denominator. Okay, so 1/8 plus 1/8 is equal to what?
2/8.
2/8. Okay. Now when you look at these, what other quantity can you apply to this fraction right now? Each of these.
1/4.
Okay, each of them is what?
And 4, 1/4.
1/4. So we can visualize that 2/8 is equal to what?
1/4.
Okay, so now we have 4 pieces that have a value of 1/4 each, right? So we're going to add 1/4 plus 1/4. Sorry, minus. When we add 1/4 plus 1/4, what do we get? Okay. 2/4. Everybody agree? So this is okay. So 2/4 is the same as what other fraction? What's an equivalent fraction?
4/8.
Okay, and you can visualize that from putting the watermelon pieces back together, right?
Yeah.
Okay, so this is equal to 1/2. Okay, so we have equivalent fractions. 2/8 is equal to 1/4, and 2/4 is equal to 1 half.
I have another answer. 2/4 can also be equal to 4/8.
Okay, so 2/4 can also be equal to 4/8. Right? All right.
Let me just say one thing. What I like about this activity is the kids get to see why they have to have a common denominator.
Right, because the pieces still remain the same.
Yeah.
Yes.
Okay, so that's how we get the common denominator. The pieces remain the same. Okay. Okay, so far, we cut one watermelon into pieces and we're able to visualize the value of each piece in a fraction, represented as a fraction. Then we put them back together and we're able to see how some fractions are equivalent. For example, 2/8 is the same as 1/4, 2/4 is the same as 1/2, and 4/8 is also the same as 1/2. Okay? Your final objective now is to see if we can identify, through observation, we can identify a formula for dividing fractions.
Multiply by 2.
You multiply what by 2?
The numerator and the denominator.
The numerator and the denominator.
To get the equivalent.
So, did you see that happening were you able to visualize that happening?
Yeah.
Okay, because when we start that with 1.
1.
We divided that 1 in 2. Okay, and we got a half. We divided that half in 2. And we got a 4th. We divided that 4th in 2. And we got an 8. So Miss Willoughby said that what's happening is that the denominator is being multiplied by 2 each time. Okay? So what about the numerator?
It remains as is.
The numerator remains the same. Okay, so what causes the numerator to remain the same?
Because it's like you are multiplying the numerator by 1.
Okay,
And the
so if we
denominator.
put 1 here, what number does that make that? Does it change?
No,
Okay, so 2 over 1
it's
is
still
2.
2. Yeah.
Okay, any number over 1 is
The number itself.
the number itself. Okay, so
And I was thinking of kids like this. Using this, you can see why.
right again.
Yeah.
Right. Okay, so who can tell me what we're doing or what we did by dividing these into pieces? What happened based on your observation?
Either you flip the last one.
Okay, what's happening is that you are cross multiplying. Okay? So when you cross multiply, you have a formula for dividing fractions.
One more thing.
Yes.
That also makes for kids who have a hard time comparing fractions. Then you can see that the 2, although 4 seems bigger than 2, when they keep cutting it, you keep seeing that your denominator continue to increase.
Right, because you're multiplying your denominator.
Yeah, but the
By how much
pieces-
ever you're cutting it into,
Into.
you're multiplying the denominator. So let's say this was, and like I said, this is a formula now for dividing fraction. So you could apply this to anything. Okay, you could say 3/4 divided by 2.
2, 3, 6, 2, 4, 8.
What would be the answer for that?
6, 2, 3,
Using the formula.
2, 3,
Remember, you have a formula
3
now.
over 8.
Okay, so it'll be 3/8.
You know why I like that method? In school, they taught us to just flip the last fraction. We never knew why we are flipping the fraction.
Right.
Find the reciprocal. But you are doing it this way, I understand why we flip the fraction. Because
Right.
I learned in school, you find the
so-
reciprocal of the last fraction.
Right.
But now
Right,
that
so-
I see, okay.
But this way is how it manifested visually for us.
Yeah.
Okay, so it could be done either way. You get the same result.
You get the same
Whether you
result.
cross multiply or you flip and
last
then multiply. Same difference.
Show my eat melon.
No.
Okay, so we can also identify some other fractions that are not here based on these, right? So, what is the value of this portion here?
Which one?
This portion.
Like 3/8.
Okay, so this is 3/8. What is the value of this portion?
4/8. 5/8.
5/8.
No?
5/8. Okay? Any questions? No questions.
I really just think that the kids have to always come back to remember, because sometimes you just say, well, the kids are like, okay, this is maybe like 2 out of 8, and they might say something like this is 1, 2, 3, 4, 5, 6 out of some kind of number, but I think with
It would be 6 out of 8.
no, I know
Okay.
we know that, but the kids will be saying something different.
Well,
Like it might-
well
it might
then,
say-
okay, they may say something different,
Yeah,
but you can always pull them back in, count all of them.
Yeah, that's what I'm saying.
You
With
know,
this,
I mean, this is a kind of
You have a visual.
this.
Yeah,
If you was to actually do this in a class, you might want to break each of these down into a smaller lesson. You know, it's just being that I know you all will be able to follow. I just
I just really like how
Yeah.
we could see the kids seeing this helps them a lot.
exactly, and that's the whole
the first
idea.
time.
That's the whole
Oh, yeah, okay,
idea
this is cool.
of using visual models.
Love it, principal.
Okay, so something that might be difficult to understand, you're trying to teach them a concept. When they can actually see it, it becomes a lot easier.
So this would be a good activity to do. Like you have activity like that we learned before, where we're looking at circumference and so forth, and then lead it into fractions. Where when they cut it up, they still keep working with that melon, because
But this is actually a much simpler lesson than that one.
Well, I look at that as a lesson in geometry and measurement, and here was fractions.
Yeah, but right, okay, but then now that's determining the circumference.
Yeah, so it's just geometry.
Okay, so that's you don't get that until you reach at least junior high school.
Oh no, but
At least-
not anymore.
You
Not
get it?
anymore.
So you get that in sixth grade as
Elementary
well?
now they're getting
Okay,
that.
because this,
Put
the last objective, which is to develop a formula for dividing fraction, that's sixth grade. What we did, that's why I say you could divide these lessons, you know, to suit what you're doing, you know, but the others started from third grade. Like this first one was third grade, identifying fractions. Then by the time you get to fourth grade, you will be identifying equivalent fractions. Okay? So no questions. All right. So since there are no questions, I will need to measure how well you all achieve the objectives. So I have a little assessment for you.